Okay, let's jump right into this because we're looking at a massive, fundamental paradigm shift in computer science today. If you take a really close look at the architecture of the OMI protocol, you'll see a radical departure from how we normally handle data. We're talking about completely throwing out hash-based identity and replacing it with something called structural place value identity. It's a shift that absolutely redefines how decentralized networks, hardware, and mathematically verifiable systems operate at their very core. To really grasp how big of a deal this is, we have to start with a question that might sound a little crazy at first. Cryptographic hashes, those long, scrambled strings of characters, they are the absolute industry standard for data identity. We literally rely on them for everything: securing passwords, verifying software, blockchain ledgers, databases, you name it. So we have to ask, why in the world would a cutting-edge deterministic system like OMI explicitly ban them from its protocol core? Why outlaw the exact mathematical tool that all of modern computing relies on? Well, the answer brilliantly illustrates a clash between two totally different computing philosophies. The old world, the one our current internet is built on, relies on what's called a sign-value model. Think of a hash like a fingerprint. A fingerprint perfectly identifies a person, right? But it completely obscures the actual person. If all you have is a fingerprint, you have zero idea what the person looks like or how tall they are. But this new OMI world uses a place value model. Think of this more like a precise GPS coordinate, where the structure, the exact location itself, is the identity. You don't need a fingerprint because the map tells you exactly what and where the data is. Let's look a bit closer at that old world first, since it's the one we're living in every single day. In modern computing, we are constantly using this sign value model. We take complex bodies of data and we run them through a hashing algorithm to transform them into a fixed surrogate sign, like a digest or a cache key. We do this because it makes big, unwieldy data stable and easy to reference. Every time you load a web page, your system is checking hashes. But by substituting the real data with a mere sign, we're making a massive, hidden trade-off. And here is the crucial point. Hashing has a massive hidden flaw. It's something we've kind of just accepted as a necessary evil for decades. Hashing violently collapses and destroys the actual structure of the data. It completely breaks mathematical composition. If you have two pieces of data, you can't just add their hashes together to get a new hash that represents the combined data. It acts as a one-way, irreversible street. Once you hash something, you can never, ever derive the original structural relations from that digest. The hash points away from the true relation and into a random surrogate label. So, what is OMI's fix for this? It's called placed value identity. In this model, the structural coordinate relation itself serves as the complete identity. It requires absolutely no digest and no hash to become stable. The structural elements of the data, which the protocols calls the frame, the route, the witness, and the closure, literally act as the identity. The data carries its own address just by existing in its specific mathematical shape. It doesn't need to be compressed down into a fingerprint because its physical geometry on the network speaks for itself. Which brings us to the canonical doctrine of the protocol. It is a boldly contrarian, completely non-negotiable rule stated right there in the source documents. OMI notation citations are not identified by hashes. Hashes, checksums, encrypted labels, none of these can ever become identities inside the deterministic core of this system. It's an uncompromising ban, specifically designed to preserve the pristine mathematical properties of the data structure. By ditching hashes entirely, this place value model creates what is beautifully termed a cascade of addressability. Because the data isn't squashed into a random string, you get a purely nested structure, where an inner element is mathematically wrapped by an outer envelope. This ensures that a wider envelope of data never overwrites or replaces its root. It carries the root forward mathematically. When you cite a piece of data, that citation resolves directly through the nested relation itself, maintaining total, perfect transparency all the way down. If we look at the OMI processing pipeline, you can see how this actually plays out in the wild. We go from citation, where the notation is parsed, to validation, to recording the receipt, all the way down to projection. And notice the massive architectural choice here. Across this entire sequence, from start to finish, a hash is never generated. A hash is never checked. The data moves through the pipeline completely intact, relying purely on its place value geometry. This is absolutely vital during step 2, validation. This is where an authority module, known as the tetragrammatron, steps in. Think of it like a strict mathematical referee. Its job is to judge whether the data relation resolves deterministically. Now, this is a pure mathematical check of the data's geometry and rules. If the data had been squashed into a hash, this step would literally be impossible. This referee doesn't want to check a lookup table to see if a digest exists. It needs to prove the structure itself is mathematically lawful. The protocol documentation actually goes out of its way to powerfully warn developers about violating this. It declares that introducing a hash into the core creates a competing second identity channel. It makes a digest falsely appear to preserve what the address already preserves directly. The text literally calls this a fundamental category error. And it isn't just frowned upon, it is mathematically fatal. Relying on a hash here literally breaks the pure determinism that the entire protocol is built on. Now, this doesn't mean hashes are totally useless. It creates a strict, highly practical boundary. Operators can still use hashes, but they have a quarantined place. Notice how the protocol core strictly uses place value identity for deterministic validation. Meanwhile, the external carrier layer, the systems actually moving data across the internet, can still use hashes for transport optimization, private caching, or encryption. But those hashes are external artifacts. They are strictly forbidden from entering the protocol core and claiming to be the actual identity of the data. So, what is the ultimate payoff for maintaining this strict mathematical architecture? It's the creation of a pseudo-persistent open world. Once relations are validated, they are recorded into a unified storage structure called the OMI ring. And here's the absolute genius part. They aren't stored using a traditional hash lookup table. They place themselves into the ring exactly where their geometry dictates. The slot and the data are the exact same thing. It's an incredible breakthrough in how we map and store information. There are exactly 5,040 slots in this OMI ring. And no, that's not just some arbitrary database size a programmer guessed at. It's a pristine, exact number derived directly from a mathematical concept called finite incidence geometry. Without getting lost in the deep math weeds here, what you really need to take away is this. This number is predictable and exact everywhere. Because the system relies on universal geometric laws rather than arbitrary hash outputs, the grid organizes itself with absolute mathematical certainty. And because every piece of data has an exact, calculable mathematical coordinate, this enables perfect peer-to-peer synchronization. Networks can sync state purely through the exchange of receipts and independent local mathematical validation. There is no central database, there is absolutely no global blockchain consensus required, which is a huge departure from standard decentralized networks today. Identical world states naturally emerge across different peers simply because the math is exact and structural everywhere. Plus, relying on pristine relations instead of collapsed hashes guarantees absolute hardware safety through a principle called lazy evaluation. Because the system never acts on an opaque, scrambled hash, it ensures incredible real-world safety. Imagine an automated robotic factory arm. You definitely wouldn't want it to swing or actuate based on a scrambled string of letters. You want pure structural validation before the hardware clicks. OMI guarantees that physical devices won't trigger a side effect until the full data structure is fully validated, confirmed, and recorded as a receipt in the ring. So where does this leave us? For decades, we've built our digital trust on cryptographic hashes, actively accepting their hidden flaws and the way they obscure the data we actually care about. But what does the future of distributed computing look like when we finally drop that surrogate fingerprint and return to trusting the exact, pristine mathematical structure of the relation itself? If OMI is any indication, it's a future that is vastly more verifiable, deterministic, and structurally sound. Keep exploring, everyone.